Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All about electricity. Part 19. Lithium iron phosphate batteries. System protections. Just for information, this is the 32nd different topic we have presented on prepping since we started this net. This doesn't include the 8 comment videos and additional information videos that we have created and posted. Tonight, we will continue discussing solar panels and answer the question: what protective equipment should you have for your solar battery system? Before we begin with protective equipment, I want to add a point that should have been included in last week's topic. When you purchase your solar panels, it's a good idea to also buy extra matching solar panels. This will give you panels that can replace existing defective or damaged panels, which will work correctly with your design. Or you can use these extra panels to expand your charging capacity. Now to protective equipment. Tonight's presentation will be a bit long, but please hang in there. Why do I need protective equipment on my battery system? The short answer is to prevent a fire, but protecting you from electrocution and protecting your connected electronic equipment might be something you also want. The most prevalent protection devices are fuses or circuit breakers. Fuses are a one-time protection and need to be replaced once they are blown. A circuit breaker will trip, but can be reset, and there are types of automatic breakers that will reset themselves when things get back to normal. I would not recommend the auto reset type, as those might trip and reset many times before you know there is a problem. When a fuse blows or a breaker trips, something will no longer work, so you know faster that something is wrong. How do many fuses or circuit breakers work? With all fuses, when current flows through a wire that is too small, it will heat up, and if enough current flows, the wire will burn through and disconnect the power to your equipment. This diagram shows the different sizes wire inside a fuse. The higher amperage that a fuse can handle, the larger size of the wire will be. Here is what a blown fuse would look like. Here are a few examples of other styles of inline DC fuses you could use on your system. Circuit breakers do the same thing, but with a reset button. Some breakers are thermal, similar to the fuse, and others are magnetic. The thermal type works as follows. A bimetal strip warms up when too much current flows through it, which will bend it. When it bends far enough, it trips the switch. The magnetic type works by a sudden surge that creates a strong magnetic field. This magnetic force snaps the breaker open instantly. Fuses will blow faster than a breaker will trip. That's the pro of fuses. The fuses will need to be replaced. That's the con of fuses. A big warning here about circuit breakers. When using circuit breakers on your solar system, they must be DC rated and be rated for the voltage you are protecting. So, if you are protecting a 24-volt DC circuit, the breaker must be rated to handle 24 volts DC. Using a breaker only rated for 12 volts on a 24-volt circuit, you are opening your system to a fire, and you cannot use AC-type breakers on your DC lines. If this whole DC breaker thing is confusing to you, get a licensed contractor who works with solar systems to size and install the proper breakers and fuses. I have provided a link to Will Power's webpage on things to know about fuses and DC circuit breakers in the video description. Will Power is an electrical engineer and very knowledgeable about solar systems. Many of the other pieces of equipment you have on your solar system, such as charge controllers, battery management systems, or battery protectors, can protect your system from overcurrent, short circuits, reverse polarity, or overvoltage. However, they do this electronically. They are nice to have, but are not a replacement for a fuse or circuit breaker, as the electronics rely on logic and not physical protection like a fuse or breaker. Now, to the example of my system. We talked a little about a combiner box last net. Not only does it make it easy to combine solar panel strings, but does provide hard protection. For this model of combiner box, each solar panel string is fused to 10 amps. Then, the voltage and amps of the combined panel go through a circuit breaker. This breaker is rated at 63 amps, which is more than the maximum combined amperage of my panels. It is also rated to 1000 volts DC, so if something fails to protect on the input side, you have another layer of protection. This final breaker also acts as a disconnect switch, which is useful to disconnect your solar from your wiring coming into your house. DC disconnect breakers switch both the positive and negative wires, so there is no connection whatsoever from the disconnect equipment. This is different from a standard AC breaker, which only disconnects the hot wire. At the charge controller, I have another breaker disconnect switch for the solar power into the charge controller. This protects the charge controller from overvoltage and overcurrent and is my third protection layer between the solar panels and my charge controller. Now, as the power comes out of the charge controller directly to the battery bank, there is another breaker disconnect switch. This protects the battery from overcurrent and protects the charge controller from a short in the battery bank. As we discussed last net, you need to turn on the battery connection first, then you can turn on the solar panels. We now have our fourth protection layer from the solar panels to your batteries and protection between the charge controller and the batteries. For added protection, we could have inline fuses from every solar panel between the panel and the combiner box. I elected not to have these, but if you are risk-averse, you might want to do this. Now, what protections do I have coming out of the batteries to any loads I will put on it? Between the bus bars of the parallel connected batteries and any loads, I have a battery protector. This electronic protection will monitor the amount of load being used from the batteries. My battery protector will shut off the power from the batteries if the load is greater than 200 amps. The largest load on my system would be my 5000 watt 24 volt DC to 120 240 volt split phase AC inverter, which maxes out at 192 amps. This may be near the limit of my battery protector, but my designed maximum use is much below that. You could also have an inline fuse here for added protection. There is a link in the video description to the Victron Energy Smart Battery Protector on Amazon, so you can look at what it can do. In addition to my 2000 watt and 5000 watt AC inverters, which are not run at the same time, I also power both 24 volt systems and 12 volt systems directly. All 24 volt loads are protected by fuse blocks near the battery and by fuse blocks at the point of use. Additionally, the 12 volt loads have another fuse block protecting them at the point of use. This gives me at least 2 layers of protection for the 24 volt loads and a minimum of 3 layers for the 12 volt loads. Some of the 12 volt and 24 volt loads may have additional fused protections after the final fuse block. That's enough confusion for tonight. Next week, we'll continue our All About Electricity series and discuss powering my stuff? As we have done in many of our discussions, we'll use my system as the example of what you might do. We will have more detailed information on all of my loads, wiring, and why I did it that way. If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.